This is the solution to homework set number 10 for ECE 476-676. In this homework, we look at two problems. One, using GPS, measure how fast you can run. And the second is using Bluetooth. Use Bluetooth to control the speed of a DC motor. So going on with the first one, how fast can I run? For this homework problem, I'm trying to record how fast I can run. So what I have here is a Raspberry Pi Pico connected to a GPS sensor. It is recording your current speed. So as I walk around, speed goes up. Once it goes above 2 miles an hour, it logs that as a new recording. Once it drops below 1, it logs that and then sorts them, comes up with the top 3 speeds. So let's see how fast I can go. So if we run faster, okay, there. That was 6 miles an hour, my second highest speed. The approach using here is, first, I'll connect a GPS sensor to your board. So here's your GPS sensor. I'm reading it through GP1, serial port read. And finally then, I will download a code from Bison Academy. This just reads the GPS sensor. This is the speedometer code, modified a little bit. And what I'm going to do initially is just read the serial port. So as I connect, this will sit there and ping the GPS module. And here's the data coming in. It takes a little bit of time until I get a valid reading. So let this run for a little bit until I start getting the data being filled in. About 5 minutes later, I start getting full messages. So once I start getting data, I can then turn off this test code and bring in the main loop. What the main loop does is it reads the GPS sensor to read time, position, latitude, longitude, and velocity, convert velocity in knots to miles an hour. And here's where I kind of have two thresholds. What I do is if I run along and then stop, I've got two thresholds, one at 1 mile an hour, one at 2 miles an hour. When my speed goes above 2 miles an hour, I start recording my speed and pick off the maximum value. Once it drops below 1 mile an hour, I then log that maximum speed into an array, sort the array, display it on the screen, and then wait till I go above 2 miles an hour. That's kind of what's going to happen here. I check if I'm going less than 1 mile an hour, and this is the first time I drop below 1 mile an hour. I record the Vmax as the fourth entry in my top 4 data. I then sort it. I was using a bubble sort, but someone else showed me that there's actually a Python routine that does sorted. So this is sorted largest to smallest. Set the flag saying I have recorded that, I don't want to do it again. Set Vmax to 0. If I'm above 2 miles an hour, I record the maximum speed, set flag to 1, and then display what's going on. So if we rerun this code, what you see on the LCD display is here. I went outside to get a lock on the GPS sodlets, walked to the sidewalk, stopped, jogged to the building, stopped, jogged back to the sidewalk, stopped, and then these are my max speeds. Or for a demo, let's do a video. I'm now in my car. I'm going to repeat measuring the top 3 speeds as I drive from campus down to Bread Smith down in South Fargo. This is while walking to my car. Max speed was 4.7 miles an hour. Let's see what happens while driving. Stop and go traffic on University Drive. Every time I come to a stop, it records the maximum time or maximum speed that I traveled since the last time I came. So here I am at Bread Smith, and during that trip, the top 3 speeds on University during stop and go traffic were 35.7, 32.0, 30.7 miles an hour. To a stop. Okay, so that was the first problem. The second problem is trying to control the speed of a motor using Bluetooth. So the first thing is connect the hardware. What the hardware is going to look like is I'm going to take my cell phone. Here it is. That's going to have a Bluetooth interface to my Pi Pico. I'm going to send it commands. The command will then set the pulse width for the H-bridge. That'll either make it go forward or reverse. The H-bridge then ties to my DC motor right here. In terms of coding, let's first see how it works. So what I'm going to do is over here, I'll connect to my Pico. I'll send a speed, like 50% speed. Send. That makes the motor spin forward at 50% speed. Let's drop it down to 20% speed. Okay, not enough to make it go. Let's make it 30% speed. Here, just power the motor off of 5 volts instead. It's actually a 12-volt motor, so it's not really supposed to run out down at 5 volts. There's 20% speed, 10% speed. Yeah, too slow. Let's try 15. 15% speed. To make it stop, I send it 0. That stops it. To go backwards, let's do minus 20%. Minus 20%. Minus 60%. Minus 15%. And stop. Okay, so the way that works is I've got a Bluetooth interface I'm setting up using the BLE simple Bluetooth peripheral. I've got pins 14 and 15 being my PWM outputs. Base frequency is 100. I turn on a serial port with the Bluetooth. And I have no idea why this is in there. That's my NeoPixel from old code. This is what happens when you modify old code. You wind up with extra functions that don't belong. Anyway, this is my Bluetooth interface. When I receive Bluetooth data, I'll say data received. Pull out the data, set the flag saying you just received data. Data is passed as a global variable. Back in the main routine then. When I get a flag being set, saying I just received some serial data, update the LCD display. That's that number up over here, the speed. If it's greater than 0, do the PWM on the forward side off of 0. If it's negative, PWM's on the negative side on a 0. So again, this is kind of what it looks like. If I send a command, like let's do the number 35. Here's the number that I received. It was binary 35 carriage return line feed. Pulling in as an integer, it received that as 35. That sets the duty cycle to 35%. KB is 35 times 65,000 over 100. If I make that 80% speed, faster, let's do 100% speed. Bring it back down to 0. And negative speed. Let's do negative 10. Negative 10. Not enough to go. Negative 15. Negative 60. Negative 100. And back down to 0. So with that, I'm able to control the speed of a DC motor using my cell phone over a Bluetooth interface. And that is homework set number 10 for ECE 476 Advanced Embedded Systems.